हेलो स्टूडेंट्स, वेलकम यू वंस अगेन। आज सेकेंड शिफ्ट की पेपर देख रहे हैं 11 तारीख की। अब इसमें फर्स्ट क्वेश्चन गिवन अमाउंट ऑफ ग्लूकोज रिक्वायर्ड टू रिड्यूस द वेपर्स प्रेशर ऑफ 100 grams of water 0.2 mm of Hg and given that vapor pressure of pure water is 54.2 mm of Hg. Here for a solution PA naught is 54.2 and PSA is given as 54 and molar mass of water is 18 and for glucose it is 180. Now, the amount of glucose we are calculating by dividing 200 by 54, it can be equal to 3.7 and if you round off this you will get 4. So, the answer is 4. Next question. A solution of 2 grams of solute A in 1 mole of water is prepared. Find the mass percentage of A in the solution. Here mass percentage of the solution means weight of solute upon weight of solution into 100. Weight of solute is 2 and weight of solution is 2 plus 1 mole of water, that is 18 grams. So, 2 plus 18 20, 2 by 20 into 100 and if we calculate it is equal to 10%. It is a very easy question. Next, in which of the following process internal energy remains same at initial state and final state? Here isothermal process, adiabatic, isochoric and isobaric processes are given and in the isothermal process the delta T value is 0, temperature constant. So, delta T 0, delta E value will be 0 because internal energy is the function of temperature and delta E is 0, that means change in internal energy 0. So, initial and final state internal energy remains same. Next one, which one of the given following species has highest number of lone pairs of electrons on central atom? XeF4, SOCl2, I3 minus and XeF6. And if you observe XeF4 has square planar shape with 2 lone pairs, SOCl2 has pyramidal shape with 1 lone pair, I3 minus has linear shape with 3 lone pairs and XeF6 has distorted octahedron shape with 1 lone pair. And among these the highest number of lone pairs are observed in I3 minus. So, the maximum number of lone pairs observed on central atom is 3. Next one, 4 moles of P4 plus 8 moles of SOCl2 on reacting gives x moles of SO2, 4 moles of Y and 2 moles of Z. We have to find x, y and Z. And here when phosphorus reacts with SOCl2, it gives SO2, POCl3 and S2Cl2. Here the number of moles of SO2 formed are 4 and the compound Y is POCl3 and compound Z is S2Cl2. This is from chemical kinetics, frequently asking question. A plus B is giving product and rate equation is given as K into A power 1 into B power 1. Now, in the experiment 1, A concentration is given as 20, B concentration is given as 0.5 and rate is given as 0.1. And in experiment 2, A concentration is given as X and B concentration 0.5 and rate is given as 0.4. And in the third experiment, A concentration is given as 40, B concentration as Y and rate is 0.8. We have to find X and Y. Now, from 1 and 2 experiments, if you divide the second experiment with first experiment, then we will get X value as 80. And from 1 and third experiments, if we divide third experiment data with first experiment, then we will get Y value as 2. So, here X value is 80 and Y value is 2. Which of the following set of species has compound which are polar in nature? Polar molecules are those which are having non-zero dipole moment. If they have zero dipole moment, they are non-polar molecules. Now, in the given set of species SO2 and CO2, CO2 is non-polar, SO2 is polar and SO2 NH3 both are polar species. CO2 and ALN, in this CO2 is non-polar, aluminum nitride is polar and here also CO2 is non-polar, NH3 is polar. Which one of the following is most unstable species? In the given species beryllium hydride, it does not exist as a monomer, it polymerizes by 3-centered 2 electron bonding. So, the unstable one is in the given options beryllium hydride only. Next, this is the question from equilibrium. H2 plus I2 is giving 2 Hi. If equilibrium is attained in a 10 liter vessel by starting with 4.5 moles of each of hydrogen and iodine and equilibrium mixture contains 3 moles of hydrogen iodide, then the value of equilibrium constant is. Here H2 plus I2 is giving 2 Hi, initial moles are 4.5 and at equilibrium it is 3 moles and Hi formed is 3 moles. Now, on calculating equilibrium constant, you will get it as 1. So, answer is 1. Calculate magnetic moment spin only of respective complexes FeH2O6 times 3 plus and FeCN6 3 minus. In FeH2O6 times 3 plus, iron is in plus 3 state and that is in plus 3 state iron has 3d5 configuration and according to CFT, here water is the weak field ligand. So, according to CFT, its configuration is T2G111 EG11. That means, in the T2G set of orbitals एक इलेक्ट्रॉन होगा, EG सेट में एक इलेक्ट्रॉन होगा. So, total 5 electrons है. So, magnetic moment equal to root over n in 10 plus 2, n value is 5. So, by putting the n value, we are getting root over 35 bm, it is 5.85 bm. And in FeCN6 3 minus, Cn minus is the strong field ligand and iron is in plus 3 state. So, in presence of strong field ligand, the configuration of iron 3 plus can be T2G 221 EG00. Here there is only one unpaired electron. So, the magnetic moment can be calculated by substituting n value as 1. Now, if we substitute n value 1, it will be root over 3, it is 1.73 bm. So, the answer is second one 5.85 bm and 1.73 bm. Next question, this is from thermodynamics, very basic question. How many of the following are intensive properties? Given one are mole, volume, molar Gibbs free energy, molar mass, molarity, specific heat capacity. Here molar Gibbs free energy, molar mass, molarity, specific heat capacity, these are the intensive properties. And intensive properties means those which does not depends on mass or size of the system. Next, 12th question, find the ratio of de Broglie wavelength of a proton and electron if their kinetic energies are same, and here masses are related as mass of proton equal to mass of electron into 1849. Now, according to de Broglie's wavelength, lambda equal to h by root over 2 m ke, and here de Broglie wavelength of proton and electron is equal to root over mass of electron by mass of proton, it is root over 1 by 1849 because kinetic energy is given as same. Now, on solving we are getting 1:3. So, answer is 1:43. Next question, how much hydrogen of gas is evolved at STP when 2.4 gram of magnesium reacts with HCl? When 2.4 grams of magnesium reacts with excess of HCl, then how many moles of magnesium chloride is produced? Here 1 mole magnesium when reacts with excess HCl, it will give 1 mole magnesium chloride. 2.4 grams of magnesium means it is nothing but 0.1 mole, and 0.1 mole when reacts with excess of HCl, it is also giving 0.1 mole of magnesium chloride, and hydrogen is also 0.1 mole. So, volume of hydrogen gas evolved is 0.1 mole into 22.4, it is equal to 2.24 liter. Which of the following has least melting point? Sodium, potassium, rubidium, cesium, these are the alkali metals, and in the alkali metals from top to bottom, as the size of kernel is increasing, metallic bond strength decreases. As the metallic bond strength decreases, the melting point also decreases. So, the least melting point is for cesium. Okay students, that is it for today. We will meet again in the next paper. Thank you.